Hey everyone, welcome back, and today let's solve Leetcode problem 3227 titled Vowels Game in a String. So to kind of summarize how this problem statement kind of works here, instead of having to actually read out this entire problem statement, effectively, Alice and Bob are taking turns removing a non-empty contiguous substring from an input string S, and on Alice's turn, she has to remove a substring that contains an odd number of vowels, and on Bob's turn, he has to remove a substring that contains an even number of vowels. And Alice has to go first, and basically the first player that cannot move would lose the game. And we need to simply determine if Alice can win or not, assuming that they both play as optimally as possible. So, how can we kind of look at the examples here and see how this kind of works? In example 1, we have our input string S to be Leetcoder. In this case, we actually have 4 vowels. We have 2 E's and this O and this final E at the end here. In this case, it's true because Alice can actually win. And the way she can win is by first actually removing the entire substring Leetco. And that is actually a valid operation that she can make on her turn because it does contain an odd number of vowels, as 3 is odd. And the substring that she's going to remove on this turn does actually have an odd number of vowels because 3 is odd. Now Bob is going to play on the second turn. And again, keep in mind, he has to actually remove an even number of vowels. But in this case, since Alice strategically and optimally removed 3 of the vowels in this input string S, Bob is only left with 1 vowel to work with. And that means he can't remove any vowels in a substring at least because there's only 1 vowel remaining, and he has to remove an even number of vowels, where 1 is odd but not even. So he has to remove 0, right? Because 0 is still even. And that leaves it with ER. E is the only vowel left, 1 is odd, and so Alice can just remove the ER as a whole on her turn and win the game here. In example 2, we have our input string S to be B, B, C, D, and this is kind of that unique case where we don't have any vowels, and this is leading to major observations to come in this video. In this case, this has to be false because Alice is always going to play first like the problem statement says, and since there aren't even any vowels initially to even work with at all in the original input string, Alice can't do anything. She can't strategically make any way or any case for her to win, and so this is a case where she would have to actually lose because she starts off with a vowel-less input. And so this has an output of false here, again leading to observations to come. So in the constraints here, we say that the length of our input string S is going to be between 1 and 10 to the 5th power, and our input is only going to consist of lowercase English letters, just kind of confirming what the problem statement said and guaranteeing that we're only going to have lowercase a, e, I, o, u as the potential vowels in our input string S, which leads us to the main kind of solution an observation that we really need to make to be able to solve this problem in the most efficient way possible. And what is that main observation? Well, that main observation is that Alice here, because she is going first and Bob is forced to take an even number of vowels, it kind of automatically sets Alice up for success. She's almost guaranteed to win because she can kind of break it down into any of 2 cases to be able to kind of screw over Bob on his turn and guarantee victory, right? There really only is one possible way that Alice can't win, and that possible way would be if she starts off with 0 vowels to work with. In that case, she doesn't have any possible move, and she has to actually lose the game on the first move of the game, and so that would be an output of false, like we see in example 2. But there actually is basically every single other way besides 0 vowels in the input where Alice can actually win. She always will have a winning strategy as long as she has at least 1 vowel to work with. And the way that would work is if the total number of vowels in the input string S is odd, we know that since Alice can remove an odd number of vowels, she has to remove the entire string entirely on her first move. And that would basically mean removing all the vowels, which would leave Bob nothing to work with. And so even if so regardless of what Bob would have to do, since he wouldn't have anything to work with, he would lose as he wouldn't have a move to make on his turn because Alice could simply remove the entire input string S as a whole if it has an odd number of vowels in total, right? And even if the total count is even, like we see in example 1, all Alice has to do is just make a move that leaves an unfavorable position for Bob, right? This is what we saw again in example 1. She just removes basically an odd number of vowels so that only 1 more vowel exists on Bob's next turn, and since 1 is odd but not even, Bob would be screwed. He would be in an unfavorable position. He would not be able to make a move, and he would lose in that case as well. So even if the total number of vowels in the entire input string S is odd or even, as long as Alice is guaranteed to play optimally, meaning she either removes the entire input string S or only keeps one vowel for Bob to work with by removing all the other vowels, which would be an odd number. That would leave Bob with nothing to do. Either he wouldn't have any characters to work with, or he wouldn't have an even number of vowels to work with in either way. And either way, Alice is guaranteed to win because of those properties and because she plays first, as long as the total number of vowels in the input string S is greater than 0. Again, that main observation is that the only time Alice is going to lose is if there are 0 vowels in the input string S. And so this problem is really just kind of broken down, removing all those layer of abstractions to just be checking if the input string S has any vowels. The moment we see a vowel, we know Alice is guaranteed to win, because regardless of if the number of vowels is even or odd, as long as there is at least one for Alice to work with, she can leave Bob in an unfavorable position without any characters to work with at all by removing the entire input string S if there are an odd number of vowels, or simply letting Bob go with only one vowel and exactly one vowel by removing an odd number of vowels to be all the vowels but one on her first turn if there are an even total number of vowels in the input string S. Either way, Alice would win. So really, we just iterate through the input string S. We check if there is at least one vowel in the input string S. If there is at least one vowel, Alice is guaranteed to win for that explanation. If there isn't any vowels in the input string S, only then can Bob win. All right, and that's really it for the actual logic. And so let's go ahead and get into the code. So what I'm going to do is actually use a vowels list to check for actual characters if they are a vowel or not. So I'm going to call it vowels. And it's going to be basically a set in this case rather than a list of A, E, I, O, U, all the possible vowels in the English alphabet, right? And the reason why I'm using a set here is because whenever I'm checking for a character S, or rather C, in the input string S to check if it's actually a vowel or not, if I check if it's in this set, that would not only tell me if it's a vowel, but it would also do it in big O of 1 runtime, because lookup times for sets are big O of 1 or constant time, whereas lookup times for lists or arrays are actually big O of n, kind of just making our runtime complexity that much more efficient. So for every character C or in the input string S, if C, and keep in mind dot lower, is in our vowel set, and I just did dot lower to be kind of careful here. I want to just convert it to its lowercase to make sure, because this is only going to contain lowercase characters. Although for this problem, I don't think it's actually necessary, just to double check. Yeah, so since we're guaranteed only lowercase English letters, we actually don't even need this, because we're guaranteed that any character that we find is already going to be lowercase, and so that's actually a redundant part of this code, right? So if the character C is in vowels, meaning if it is actually A, E, I, or U, meaning again, it is a vowel, that means Alice is guaranteed to win because there are more than 0 vowels in the input string S. We can immediately return true. We don't care if there are more vowels, we only care if there's at least not 0, or if there is at least 1. However, if we did not return true, meaning we didn't find a single character C that was in vowels in the entire input string S, once the for loop is actually done executing, once it fully terminates, we then would return false, indicating that there would be 0 vowels in the input string S and that Bob would win in that singular case, like we saw in example 2. Right, where it only had 4 consonants and 0 vowels. So unless I made any syntax 0, 0, there should be accepted and there should be a valid solution. And as you can see, this really is just about as efficient as you can get it to be. So again, on a high level, what is the main logic here to kind of solve this problem, right? And that is, if there are no vowels at all in the original input string S, we know that Alice would have no legal first move, because we know that she's forced to remove a substring with an odd number of vowels, and 0 is not odd, and so she would lose immediately. However, if there is at least one vowel, she's guaranteed to have some sort of winning possible case, right? If the total number of vowels is odd in the entire input string S, she can remove the entire input string S on her first move, and that would leave Bob with 0 characters to work with on his next turn, which would guarantee him to lose. And even if the total count of vowels in the input string S as a whole was even, as long as it was greater than 0, meaning it wasn't 0, Alice would still make a move to remove all n-1 vowels, where n would be the number of vowels. Basically, that would still be odd, and that would only leave one vowel left for Bob, which would be an unfavorable position, because he wouldn't be able to remove any characters or vowels, particularly because 1 is odd and not even, and Bob has to remove an even number of vowels. And so either way, any vowel in the input string S would mean that Alice can force a win according to these problem constraints here, right? So Basically, overall, the code is quite simple. We really just iterate through the input string s. If we find any vowels, we immediately return true. Otherwise, we return false, indicating that there are 0 vowels in the input string s, and Bob would win only in that case. Which leads us to the complexity of this solution here. For the runtime complexity, it really is very straightforward, just linear. Big O of n is going to be the length of our input string s. Why? Because we really just have one singular pass for loop or iteration of our input string s, where we go through every character in the input and check if it's a vowel or not, which is just linear according to, or rather with the input constraints here, so big O of n. And the memory or space complexity is actually big O of 1, because even though we're using this extra data structure of vowels, since it's always guaranteed to have a length of only 5, we're only using these 5 characters in memory here for this actual data structure. It's actually going to be not a linear solution, because there's no allocation that grows with our input size. And so because it's guaranteed and it's going to be a fixed, we're allocating a fixed size for this memory in memory here for this vowel set, which in this case is 5. It's actually going to be a constant amount of extra space, or a big O fully simplified of 1 memory complexity, right? So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye bye.